How does the universe work? That's the question that physicists spend their entire lives trying to answer. And they thought they had it pretty much figured out up until Albert Einstein came along with the theory of special relativity and just knocked everything out of the water. For a long time, physicists thought that the whole universe could be described with two sets of laws. Newton's laws to describe how stuff moved around, and Maxwell's equations to describe how electricity and magnetism worked. Turns out they were wrong about that. Albert Einstein found out that Newton's laws and Maxwell's equations actually contradicted each other, and it couldn't be possible that both were true. Today, physicists have a similar conundrum. They have the theory of general relativity to describe big things, and they have the theory of quantum mechanics to describe small things. And they're both experimentally valid, they both predict stuff very, very well, and they're incompatible with one another. Today, a whole bunch of physicists, including Michio Kaku, the author of the book The God Equation, are trying to harmonize quantum mechanics and general relativity because they harken back to the days where there was one nice, neat theory of how everything worked. And I'm not so sure it's going to go well. Right now, the best bet to find the God equation and to harmonize quantum mechanics and relativity is called string theory, which is an 11-dimensional mathematical theory about how the universe works. The problem is that it's pretty much impossible to test string theory, and it violates a lot of our assumptions. It doesn't really look like the great physics theories of the past, so a lot of people are pretty suspicious of it. Like, for example, the stuff about 11 dimensions, like, where are the other 7? In the past, physics theories have been simple, beautiful, and elegant. For example, Newton's laws are simple, beautiful, and elegant. There are only 3 of them, they describe everything, and once you look at them, they make total sense. However, I'm not sure that means future physics theories to describe the universe in greater and greater complexity will also be simple, beautiful, and elegant. I know way more about social sciences than I know about physics. And in social sciences, if you want to build a model to explain the world really, 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 really well, you need to add a lot of variables and you need to make that model really complex because humans are complicated and there's just no way to describe us with just a few equations. The same thing's probably true in physics. The more we understand the universe, the more complicated it will seem, and the more things we'll have to add to our model. Trying to describe, a 13.8 billion-year-old system with 10 to the 80 atoms in it with just a few equations is not going to work. One important thing to note is that the universe has to be simple at a large scale because we are here, right? If the universe was super complicated, if stars behaved in an erratic manner, if planets didn't form, etc., then humans would be dead. But the same isn't necessarily true of the quantum world, right? If small particles behave in weird and erratic ways that aren't super predictable, that doesn't say anything about whether humans can live or not. So I think physicists need to get comfortable with the idea that the universe is a complicated place. There's no way to easily describe it, and if you want to describe the way the universe works in detail, you're going to need a really, really long model that most humans won't be able to comprehend. And speaking of things that humans can't understand, physicists need to get comfortable with the idea that the human brain evolved to understand life on Earth, and not necessarily to understand the stuff that is out there in the universe. There's probably a bunch of stuff that exists in the universe that's really important to the way physics works that humans just won't be able to understand no matter how hard we try, because we have no reference frame for thinking about them, right? So, for example, where is the 4th dimension? Is there a 4th spatial dimension? Well, string theory says there are 10 spatial dimensions, but where are they? We can't conceive of them. We have no idea where they are. And with a 4th spatial dimension, we at least have a reference frame for thinking about it, right? We have 3 spatial dimensions. We can imagine, oh, maybe there's a 4th. But what about stuff that we just don't have a reference frame for? We have no idea to even ask the question, does this exist? I mean, it took a brilliant mind like Einstein just to come up with a theory of general relativity, which is really, really hard to warp your head around. I don't think we can get much further than that. I hope I'm wrong about this, but I think that physicists will ultimately have to settle for what economists have already accepted that they have to settle for, which are super complicated models of how the world works that omit tons and tons of variables, that don't describe everything, and that can never be 100% accurate. Still, though, it would be really cool if you could describe the universe in a short, simple, and beautiful equation. That would probably make me believe in God. So that's it for today's Theo's Book Club. If you're new around here, my name's Theo. I make brief videos like this one, going over the big ideas in the books that I read, so that you can learn what I learned, and so that you can decide whether or not you want to read these books yourself. If you like this video, I hope that you'll go down and hit the like button. That tells YouTube it's a good video, they should share it with more people. I'd greatly appreciate that because this is a growing channel. Also, you can hit the subscribe button and you'll see more of my smiling face pop up in your feed. And until next time, happy trails, and I hope you go work on something beautiful today.